Hello, this is Jack Jackson. In this video, we're going to talk about how we can look at a graph of a function and from the graph estimate the area between that graph and the x-axis. Okay, and of course that is, at least the net signed area is exactly what we mean by an integral. So this is a GeoGebra applet that I've designed to help us do this. So what we're looking at is we have a function here, which we can change the formula for that function. You see it graphed in red. And we have a and b values that define some interval. So in this case, we're talking about 2 to 6. You can see that thicker line on the x-axis moving up and down there, from 2 to 6. And then we want to find the area above that. So, well, the area we're talking about, here it is shaded. Okay, and again, that's going to change as we do this. Now, I have this particular applet set up so that it always goes up in multiples of a half. Okay, so A and B are multiples of a half. So 1, 1.5, 2, 2.5, and so forth as I do the slider. Okay. So now what we want to do is find that area. Now let's talk about a couple ways we could do this. One way we could do it is to sort of count these squares. So notice that each one of these little, well, not the little bitty squares, but the bigger ones here are what, a half by a half. So each one of those is a fourth of a unit. So we could count those, count how many squares that we have and multiply by a fourth. That works great for the ones where the whole square is in there. The problem comes in is when you get to something like this square, how much of that square is there? Well, almost all of it, but there's a little bit out. Here, oh, it's a little over half, but not, this one's definitely under half. Is it, what is that, a fourth, a third, 0.2, 0.3? It's a little hard to figure that out by looking at it. Now, we could estimate that, but if we did this, we would have to add up all the whole number squares and then add up the fraction squares and figuring out what fraction of a square is there, get a total number of squares by adding those up, multiply by a fourth, and that would tell us the area. That's one method we could do, and certainly that's a legitimate idea, but it's a little hard to do. I've had students try to do it that way. It's a good conceptual exercise, but it's kind of hard to do. So what we're going to do here instead is we're going to break this up into some vertical strips like this. And on each vertical strip, we want to find a rectangle. And if you notice, we have these little dots down at the bottom. Each one of these, you can just grab it and move up and down to find a rectangle. The ones we want, of course, are the ones that are over here in the shaded region. So I want to take this, and I want to move these things up or down. Oh, come on. Is that not moving? Whoa, where's that going? There we go. And we can move these up and down. Well, how high do I want them? Okay. I want them to be, well, we could do left Riemann sums, or we could do right Riemann sums, or we could try for midpoint. But what we really want is the average value. And what we mean there is, I want this to be, let me just get them into roughly the right area, and then we'll fine-tune them here in just a minute. Let's just say, let's look at this first one. Okay, I'm a little too low because if you notice, it's under by this amount right here, this almost like a triangle amount. And this kind of like a triangle. It's not really a triangle because this is a part of some curve, not a straight line. But you want those two little quasi-triangular pieces to be the same area. So if I could just kind of eyeball it and try to work that up and down. A good place to be close is where this crosses horizontally in the middle. That would be the midpoint rule estimate. But sometimes the midpoint rule estimate doesn't work. So like right here, this one, the midpoint rule estimate would definitely be too big. We want something maybe in between that. I'm not sure if I can adjust that one like I need it to be. Okay, so I want to take each one of these and do this the best I can. too high. That's pretty close. How about this one? That's too high. That's too low. Where's the sweet spot in the middle where they're about the same? That's close. That one's a little high, probably. Too low. Close. I think that's a little low. That's a little high. Not sure if I can get it to go exactly in between. Somewhere in there. Too high, because this one looks bigger than that one. See what I'm doing? I'm trying to balance those two areas. If I get it perfectly right, then that rectangle would be exactly the same as the integral of the curve on that little sub piece. And of course, the closer I can get these, the better off I'm going to be. This is a little low. I don't know if I can get it. I can't get it to. Keeps jumping too low or too high there, so I can just adjust that one mentally, I guess. So once we get these all where we think we need them, then it's just a matter of estimating the area. So estimating the area, I know the widths. The widths are a half. So I can do a half times the height, half times the height. Well, it's a half times each height. For the area of each one, I can actually factor that out using the distributive property, common factor, distributive property factoring, and basically just add all the heights up first, and then once I get that value, multiply by 1/2 one time. So if you look here, I just really need to figure out how tall this thing is, and I just need to read off of the scale here. So I would say to the nearest tenth, this is about 2.4. All right, this is about 3.4-ish, 4 point something here, what, 4.4 maybe, and so forth. Do that for each one, add up those numbers, and divide by 2 or multiply by half. So I'm going to let you guys figure out what you think these are. And then we're going to check your answers in just a minute. So what I want you to do is pause the video, figure out what these heights are. If you think I need to adjust them slightly from what I've got, you can do that kind of mentally. Or if you've got the app open, do it yourself. Even better. Okay? And then estimate those heights. Add all the heights up, multiply by the width, which is a half, and get an area, and let's see how well you do. Better yet, if you can actually get this app itself, you can put these rectangles where they need to be yourself. Okay? All right, press pause and come back when you're ready. Well, hopefully you did that. Let's take a look. First of all, let's see how I did at putting my rectangles. Here's where they should be, is the average value. Looks like I'm off a bit on this one. I was a little low. There's a tad low here and here. If I'd have done it with mine, I might have been a little under on my estimate. The actual value of the integral is 19.16 repeating. How close did you get to that? Were you able to get it to be 19, rounded off to a whole number? Were you able to get it to be 19.2 or maybe 19.1 or 19.3? Could you get that close? A lot of times, if you're careful with this, you can get usually within well, on something, this depends on the scale, but on something on this scale, there's a good chance that you can get that within to the nearest tenth or within a tenth or two of the actual answer just doing it this way. So again, the idea is you can adjust these rectangles however you want. The green rectangles are where they should be adjusted. I'm just going to get them kind of out of the way. The green heights are exactly the average value on each piece, and that is the height so that the integral on just that one piece is exactly the same as that area. In other words, now it does perfectly balance. This little piece here and this little piece here are perfectly balanced. The amount it sticks out and the amount it's under, the over and unders are canceled out perfectly on each piece, and that's exactly where you should draw them. Of course, even with this, when they're drawn perfectly correctly, you still have to just read off the heights. Now, there's several places where there could be problems, right? As we saw when I did mine, I was just a teeny bit under on one, or I could have been a teeny bit over. So it's a little bit hard to estimate that visually. That's the first place you could have a problem. The second thing is once you have this here, you do have to estimate the y values. You don't have to estimate the x's. We know those are delta x is exactly a half. But we do have to estimate the y values from the graph. All that being said, this is a pretty good estimate, and we're using Riemann sums. Not necessarily a left or right or midpoint Riemann sums, but just whatever we think is the best. We're trying to shoot for this green thing, which is the average value Riemann sums, which is, of course, just perfect. And so that's what we're shooting for. So this gives you a method by which you can approximate the area here. By the way, before I leave, though, I do want to remind you that I keep saying area, but when we look at a situation like this, where we have part of the graph is below the x-axis, these things, whatever we take the heights here, we're going to do them as a negative. We're actually taking the y value at this point, right? At this, in this case, it's the bottom of the curve, I guess, bottom of the rectangle rather than the top. But that where the rectangle is there, where it meets that y value, that curve, we're looking at its y value, which is a negative number. So these areas here are going to subtract from the integral, whereas these over here, where it's above the x-axis, are going to add to the integral. Okay, hope you found that useful. Hope you can experiment with this. Experiment by changing the a and b around a little bit. Experiment by putting in some different functions. And you can do this, practice this as much as you want to. You get really good at it. So this gives you a good little thing that you can practice. When you do it, you want to maybe want to just turn on that much, and then you can adjust these as you want. Take the ones that you need, leave the others just down there alone, and play around with that. Once you got it, you can see how well you did on placing the rectangles and how well you did on getting the final number by clicking those boxes. Hope you find that helpful. Bye-bye.